Okay, so part A, we had a generator producing an alternating EMF with a peak of 8 volts, frequency of 20 hertz, and we sketched a graph of it. Part B, we were told the frequency of the rotation of the AC generator is increased to 30 hertz, and we got on the same axis, sketch a graph to show how the EMF varies with time at 30 hertz. So if we jump back across, I've got my answer to 1A up now. So we're going on to 1B. And what we're told this time is our frequency is going to be 30 hertz. Now again, our period is 1 upon the frequency. So we've got 1 upon 30, which will be 0.03 recurring seconds. So we know that rather than taking 0.05 seconds to complete a full wave, it's going to do it in 0.033. So it's going to do it about there. Okay? The second thing we've got then is the question of, so that tells us in terms of time how it changes. The second question we've got then is how do the peaks change? So we know our induced EMF is equal to van omega sine omega t. And we know that omega is actually 2 pi f. So we can actually write van times by 2 pi f times by the sine of omega, times by 2 pi f t. Now, we've already taken care of this change to which spinning faster just by looking at it in terms of how the timeline changes. So I'm not going to worry about that. What I'm worried now is about, what I'm talking about now is the peak. So if I look at this, we've increased the frequency from 20 to 30 hertz. So we've gone up by 50%. So we've got 1.5 times the frequency there. So previously my maximum EMF was 8 volts. So therefore my max EMF now is going to be 1.5 times by 8, which is going to be 12 volts. Move it up so you can see it. So what we've actually got then is we now know where our max is. We now know where our peaks are, and we now know what our time looks like. So what I've got to do then is change this graph. So I want it on the same axis. So if that was 8, I'm going to say 12 is actually about equivalent of halfway up. So I'm going to make 12 there. So that's going to be 12 volts. Again down here, I'm going to make that minus 12 volts. So I know I've got that is my negative peak. That is my positive peak. Now, what I have to do then is draw on the various points. So at 0.033, because it's 3 recurring, so 0.033, I'm going to be back at 0 here. So I'll put a little cross there. I'm going to start at 0. And half of this, so 0.0167, so 0.016 about here, I'm going to be going through my midpoint, so halfway through it, so 0.016 about here. So therefore about halfway between these two I must be up at a max, and halfway between these two I must be back at a 0. And now I'm going to try and just draw it on smoothly. So here we go, so I'm going to go up. Oops, incorrect, I've done that wrong, because my maxes should be at 12 volts, not at that 8. So I need to be down here, not at those points, because I'm at 12. So up I go, so I draw it up. Then I come all the way down again to my twice 12, and I go all the way up. Now I can continue that if I want, so I'm going to go on, so 0.33, about that far further on, so back about here, I'm going to be back up, so I'm going to be back down to 0 again. So I expect to be down to 0 about there. It's about halfway in between, I expect to be back up at a max again, so you can see I can carry that curve up, and then carry that curve down again to 0. And it would just carry on. So two things, when you change the frequency of it, your peak increases, or when you increase the frequency, your peak increases, and because you've increased the frequency, your period decreases, so they get squashed together, they get shorter. Thank you very much.